Hello, welcome to InfoFire, the fireside chat series from Information Matters. InfoFire brings together visionary thinkers and leading experts from diverse fields to share their stories, insights, and perspectives. Each episode features a structured yet conversational dialogue with our guest centered around a specific theme. Through an organic storytelling format, we aim to trace the evolution of ideas, capturing not just key discoveries but also the journeys that led to them, intertwining intellectual breakthroughs with personal experiences and historical context. Our goal is to blend the personal and the professional, offering a unique fusion of academic depth and narrative warmth. Each episode is a conversation between our guest and your host. I am Shalini Aras, your host for this series. I am an academic with over 4 decades of experience in teaching and researching in the field of information. I also founded 2 educational institutions: the International School of Information Management, India's first iSchool at the University of Mysore, and the Myra School of Business, also in Mysore, India. In today's episode, I am delighted to be in conversation with Dr. Stephen Robertson, one of the most influential figures in the field of information retrieval. His pioneering work has had profound impact on search engines, ranking algorithms, and the evaluation of information retrieval systems over several decades. Let me take a moment to introduce him and his key contributions. Dr. Stephen Robertson is Professor Emeritus at City University, London, and visiting professor at University College London. He is also a fellow of Girton College, Cambridge. He spent 15 years as a senior researcher at Microsoft Research, Cambridge from 1998 to 2013. He earned his bachelor's degree in mathematics from Trinity College, Cambridge in 1967, a master's from City University in 1968, and a PhD from the University College London in 1976. Coming to his research contributions, he is well known for his pioneering work in probabilistic information retrieval. His research aimed to develop models that rank documents by estimating the probability of relevance to a given query. His work has significantly impacted search engines, ranking algorithms, and the evaluation of information retrieval systems. Drawing from the probability ranking principle developed by William Cooper, he, along with Karen Spark Jones, developed the very well-known RSJ, Robertson Spark Jones model, a cornerstone of probabilistic ranking methods. His work on term weighting schemes such as IDF, inverse document frequency, became foundational in vector space models and probabilistic information retrieval. He contributed to techniques for query expansion and relevance feedback, improving retrieval performance by dynamically refining search queries. He co-developed BM25, Best Matching 25, one of the most widely used ranking functions in modern search engines. It remains the default ranking algorithm in several open source search libraries like Apache, Lucene, Elasticsearch, and Solar. Dr. Robertson played a leading role in the Okapi information retrieval system at City University, London, where he refined BM25 into a highly effective ranking model. Okapi project helped solidify the foundations of modern search technology. Dr. Robertson contributed extensively to the design and evaluation of information retrieval system. He was instrumental in shaping TREC, Text Retrieval Conference, by US National Institute of Standards and Technology NIST, that sets standards for search engine performance. His research provided insights into precision recall trade-offs, relevance feedback mechanisms, and retrieval effectiveness. Beyond academia, his research has influenced search engines, digital libraries, and enterprise search solutions. His methodologies are implemented in search tools used by Google, Microsoft, and various library databases. His H index is 60 and he has received more than 26,000 citations. Dr. Robertson has also written a book titled BC, Before Computers, on information technology from writing to the age of digital data. Dr. Robertson has held many editorial roles and memberships. He was editor-in-chief, Information Retrieval Journal, now Discover Computing. He is editorial board member, ACM Transactions and Information Systems, member, ACM SIGIR Conference Committee, advisory board member, Text Retrieval Conference TREC. Dr. Robertson has won many honors and awards. Gerald Salton Award, the highest recognition in the field of information retrieval, was awarded by ACM SIGIR in the year 2000. He is fellow of the British Computer Society. He is also fellow of the Association for Computing Machinery, ACM. With this brief introduction and without further ado, let us now go over to our conversation with Dr. Stephen Robertson. Hello, Dr. Robertson. Welcome
Hello.
to InfoFire.
Thank you.
Thank you. Thank you so much for this privilege and an honor to interview you for our episode of InfoFire. You are such a pioneering figure who has actually laid the foundations of information retrieval field, especially with your contributions in probabilistic retrieval model. So we would like to, I and our audience would certainly would like to listen to you, your views, your stories, and your perspectives on how the field of IR has shaped and what is the future, especially in the context of AI and large language models, etc.
Yes.
So I'm going to be asking you a couple of questions through which we would like to know about your views on the topic. Okay.
Yes.
So my first question to you is, you borrowed the probability ranking principle, PRP, formulated by Dr. Cooper, William Cooper, and along with Karen Spark Jones, you pioneered the RSJ model, right? So, which actually laid, according to me, which in a way laid the foundations of the probabilistic ranking models in information retrieval. Among all your seminal contributions, I would say BM25 has remained, I would say, an influential model even today. So, in your view, what are the inherent strengths of your BM25? Why do you think that it has endured as a benchmark in IR research and practice?
Yes, thank you. I I think we had several bits of luck. Research is often luck. After developing RSJ with Karen Spark Jones, it was applied in various places, including in the Okapi library catalogue developed by my colleague Stephen Walker in the sort of late 80s, middle 80s. And there were a few other implementations. In the late 80s, I managed to get Steve Walker's project transferred. It started in another university, but I got it transferred to City. And Steve Walker and I continued to work together for a long time. So we had a system which had RSJ in it. Then the real bit of luck was TREC came along, and we sort of jumped into TREC. We thought we'd done testing with Cranfield and other test collections beforehand, but TREC was a whole new ballgame. And the thing that really happened in TREC was that we were given these unstructured text databases as opposed to the library catalogs stuff that we'd been using before. And RSJ didn't work very well with them. I knew it wasn't going to. So in TREC 1, we didn't do very well at all. But I knew sort of at least some of the reasons why it wasn't going to, and one of them was that we had no normalization for term frequency. Term frequency, we had no way of using this term frequency information, in contrast to Salton's system, the smart system, which had term frequency and normalized it by document length. I knew we had to get term frequency in somehow, but I had to do it at least in some sense consistently with the probabilistic model. And there was another project which I'd been involved with Keith van Rijsbergen before, which had started on that line. For that project, we were using abstracts, which were obviously have sometimes a term frequency component. So we sort of started thinking about it, but I hadn't, in the project with Keith, he and I hadn't managed to work out a really good way to incorporate it with the probabilistic model, though we had some basic ideas. So I worked very hard in the first year of Trek to try and do it. And for Trek 2, we had some ideas and we tried out some things. In Trek, so one of the challenges of Trek was just the business of dealing with the size of database that they supplied. I mean, it sounds trivial now, but it's like 2 gigabytes or something. So you can fit it onto anything very small. But at the time, it was a lot of data, and we had a lot of problems in Trek 2. And although we got part way to developing the new ideas, we had some. We couldn't submit any proper results for Trek 2 itself, although by the time I don't know if you know, when you're doing Trek, you submit results before the conference itself, and they're evaluated by the organizers, and then you get to the conference, and you only discover at the conference how well or badly you've done. But we still did badly because of, partly because of all our technical problems, partly because I hadn't quite got to grips with them, with the model. But then, so we were still a long way behind the leaders in Trek 2. But I knew we could do better. So I think it was a sort of forcing situation. I had to work on it. I knew I could make it work better than it was, but I had to get it to work. And we finally did that with Trek 3, and as a result, we did extremely well in Trek 3. And I think it was that sort of forcing period that made me work it out in sufficient detail and sufficiently well to come up with a good ranking algorithm. And I mean, you're right; it's survived 30 years of everybody using it. Lots of people are using it. It's normally used as the baseline, which means that people are trying to beat it, and usually they do beat it by a bit. Usually but it's actually quite hard to beat it substantially. It seems to be anyway. So it came out of that formative period in Trek in a very good state. I mean, it's surprising to me that it has survived for 30 years, but it has. It's not competitive with the big search engines. So if you just ran BM25 on Google database, you wouldn't do very well at all. But that's for all sorts of reasons, including the fact that the big search engines have A, huge amounts of training data, and B, a lot more data about each of the documents. So sort of click-through rate and incoming anchor text and all sorts of stuff, and page rank, of course, all sorts of stuff which enables them to do much better than you can do with a straightforward algorithm like BM25. So it's not competitive with them, but if you're in an organization with its own database, you don't have those TREC resources. And in those circumstances, it still seems to be very competitive with anything else that's come up since.
Okay. So TREC was one of the important milestones or game changer when it came to your BM25, right?
Yeah.
Now, on hindsight, is there anything that you would change or improve about BM25 if you were to design it today?
I don't think there is actually. We did at the time we did try out a lot of variations, some slightly more subtle models that took in that sort of assumed slightly more complex relationships, but on the whole they were difficult to make work. So in the course of tracks 2 and 3, we did a serious amount of, we tried a serious number of variations. I might describe it differently now if I were developing it now,
Okay.
but I don't think it would be very different in its form. I don't think so.
So fundamentally, it would remain the same,
I
according
think
to
so. Yes.
See, I mean, I had, thanks to
I'm
you.
sorry.
Sorry, go ahead.
Sorry, I just wanted to mention one thing. One extension, so people do extensions of BM25
Right.
trying to, and some of them are quite interesting. One extension that I worked on when I was at Microsoft was a field-weighted version. So if you have documents with well-defined fields, not like web, but in sort of library catalog type documents, with titles and abstracts and full text and added keywords, that kind of thing. So separable fields. Then you can, there's a variant of BM25 that allows you to weight different fields differently. So put more weight on the title, for example. It's an obvious example. And so more weight on the title words. And the logic of that was a little complicated and needed working out. I discovered that some people in Microsoft were using BM25 in a multi-field case in a very poor way. It really didn't work. So I and my colleagues at Microsoft devised a version that took proper account of the field structure. So that's one extension that I worked on, and it was quite good for those circumstances. I'm sorry, I interrupted you.
That's okay. No. What I was, I mean, thank you for giving access to your forthcoming article celebrating the 30th
Yes.
year of BM25. Of course, you have mentioned so many people, so your collaborators or competitors who influenced you. So my next question is about, what has been the influence and inspiration and collaborations of some of these people? Could you take us through the journey? And specific question to you would also be, I mean, IR in a sense had its roots both in the UK and the US, and then the different IR communities and groups have worked on it. So how has this competition, you mentioned competition and collaboration, helped the, I would say, collective advancement of the field of IR?
I think it's been very good. When I first joined the field, it was really possible to know everybody, certainly everybody in the UK, but most people in the world working in the field, because it was quite small. And so, of course, I knew Sultan and some of his people, and the people in the UK, Cleverden, who designed the Cranfield experiments. My first introduction to information retrieval in my master's course was at City University, which was run by Jason Faradane. I think Nick mentioned Jason Faradane in your interview with him. So he ran information science department at City, and he was quite an interesting character. As I think Nick mentioned, he coined the phrase information science. And he developed a professional grouping in the UK. He was quite involved in the professional work as well as the academia, but he did run this department. and so I did my master's thesis with him, and I didn't by any means always agree with him, but it was very stimulating working with him. One sort of interesting historical sideline is that he really disagreed with Cyril Clevedon on almost everything. They for some reason they clashed. In personality as well as their research ideas. And Faraday was always getting up saying in meetings after Clevedon had talked about Cranfield, saying, "You've got it all wrong. That's not how to do it." So when I did my master's thesis, and it was published as 2 papers in Journal of Documentation, Cyril Clevedon telephoned. So Journal of Documentation was published by ASLIB, and I was after my master's course, I was working at ASLIB in their research department. Cyril Clevedon telephoned the director of ASLIB, threatening to sue him for libel for my article in Journal of Documentation. The director of ASLIB was a political sort and managed to calm him down. I subsequently, quite a lot later, had quite a decent relationship with Clevedon, but he did not like my master's thesis. I said a lot of things about measurement, about recall and precision and all that stuff in my master's thesis, and I was probably quite I don't know, full of myself about it. I don't know. Anyway, I managed to get Cyril Clevedon's back up badly on that occasion. As I say, subsequently it improved. But he was I was really interested in the Cranfield experiments. They were my main focus of research for a while, and I think there are many things that you can say about the Cranfield experiments that they did in a strange way or could have been improved, but he was the first person to do it properly, do that kind of thing properly, and I think he actually did a really good job of it. I'm sorry, I've moved from the question. It's about people. Yes, okay. So I then met Karen Spark-Jones and started working with her almost as soon as I'd finished my master's. I started doing a part-time PhD, and I went to see her about getting the Cranfield results and analysing them in different ways. And we started talking about various things. And she very shortly after that published her IDF paper, which I was fascinated by. So I started working on that, and that was what led on to RSJ. It took a few years, but it did. But the thing that stimulated me more than anything on RSJ was that Karen Spark-Jones got a preprint of a paper or a manuscript of a paper by one of Staunton's students saying, you've got level of coordination, but you can rearrange the documents inside each level of coordination to make a better ranking. I said, I'm sure I can do better than that. So I put together some ideas that were not just my own ideas. There was Cooper's probability ranking principle, but the precursor to that, which was the Marin and Kuhn's paper. And I had some correspondence with Marin, who was working in Berkeley, and Cooper, who was also there. I thought we ought to be able to formulate a proper probabilistic model for this, and that's what RSJ was. Okay. So when we finally got it together in '75, Karen did some tests on it on Cranfield data, and I actually have this letter in my files somewhere from Karen. So we're talking about the early 70s. So we haven't got email or internet or anything like that. We communicate occasionally on telephone, though not normally. Mostly we communicate by writing to each other on paper, putting it in the letterbox. And I got a letter, characteristic Karen scrawl, which is quite hard to read, one day saying, your waiting scheme doesn't work at all. And I said, oh dear, I've got something wrong. And then the following day, I got another letter saying, actually, it works very well. I had a bug in my program from Karen. So that was nice. So then we published that. And we submitted the paper, which got published in '76 in JSIS, or JSIS it was then, Journal of the American Society for Information Science. And they sent it to Salton as a referee. And it's quite shocking to anybody today that I should say that, because you aren't supposed to know who the referees are. Yeah. And so you're certainly not supposed to communicate with them directly either way. But Salton didn't like the RSJ paper at all. He really had lots of things that he didn't like about it. But I mean, Karen knew him. I didn't know him at that point. Karen knew him, and the result of this, I mean, initially some comments went through the editorial board in the usual fashion, but it changed into a direct correspondence between Karen and Salton, and I was sort of feeding Karen with arguments, which she would write to Salton, and eventually Salton said, "Okay." I mean, there were some changes. He did suggest some modifications, and we made some, but eventually he sort of rather grudgingly said, "Okay, you can publish that," and so it got published, and it became, for many years, my most highly cited paper. Somewhat to my surprise, it was also Karen's most highly cited paper. I mean, Karen had done a lot of work before and continued to do work in various areas, including language processing, or what's it called, from the American organization that I'm sorry, I've forgotten what it's called. Anyway, she was very heavily involved in automatic language processing of various kinds. But this paper did actually make a mark, and went on being cited for a long time. So I subsequently, quite shortly after that, I had my first trip to America. Went and met Marin and Cooper in Berkeley, but I also went to Salton's establishment in Cornell, gave a seminar to his seminar students, his seminar class, and talked about RSJ, and found it quite easy to convince his students that I was onto something good. He was muttering away in the background because he still wasn't happy with it. But anyway, so I had a slightly awkward relationship with Salton for a while. I mean, he did invite me to give the seminar, so that's fair enough. But it recovered later, so that was okay. So that was the sort of. Those are the obvious people. One other person that I haven't mentioned was my PhD supervisor, Bertie Brooks, BC Brooks, who was a statistician. So I had a maths background, and he had a statistics background, and that helped me a lot. Although he'd published one or two things in the sort of vaguely information retrieval area, though he was much more interested in bibliometrics or scientometrics. But we had some good interactions on that. So he was another person. One other person that I had quite a lot of interaction with was Michael Keane, who had worked on the original Cranfield project, and had also spent a year, I think, in Salton's lab. So he was a sort of bridge between those two. So yeah, so those are the people I can think of. Um, Another aspect of the field at the time, which remains the case to some extent, is this distinction between library and information science schools and computer science departments, which sort of goes back and forth. I mean, they're very interesting things done in both places. They don't always talk to each other, but sometimes they do. So, for example, Cooper and Marin are in the I can't remember what it was then called, Library Information Science School in Berkeley.
Yeah.
And Salton, of course, was in the computer lab. And Karen was, insofar as she had an academic association, it was with the computer lab in Cambridge. But she bridged the fields slightly. She had an arts background, which made her more sympathetic to the library information science schools in a way, even though her base was in a computer science department. Yeah.
Thank you. It's like, going back in the nostalgic way to the,
absolutely,
the evolution of the field of information retrieval as well as information science, names such as Faraday and Brooks and all of this, brings back that, right? Yeah. So going back to the, from your narrative, I get the feeling that it is this, I would say, a combination of both competition and collaboration.
Yes, absolutely.
Between people across nations that actually help the growth of the field or shape the field, right?
It did, absolutely. Yes, indeed. I mean, you could actually say that the Cranfield project itself, it was designed. This is the second Cranfield project, which was the main one. It was designed to resolve sort of competitively, if you like, to resolve the arguments between the different very much library science approaches to information retrieval. So different kinds of classification or keyword indexing. That was so that kind of competition was already there in the original Cranfield project, and as it turned out, almost everybody who had a sort of research stake in that was disappointed by the Cranfield results because they tended to suggest that you could actually do things with straight language without the classifications, without a formal set of keywords, without relational indexing, which was what Faraday was interested in, and so on. So almost everybody got upset by the results of the Cranfield project. I mean, actually, the Cranfield project was so small scale by today's standards that you simply wouldn't trust the results anyway. But I mean, the world has moved on since then. So we now assume that we're trying to do things with text, and maybe some things like classification schemes or subject headings might help in some way, but it's not obvious at the moment in the present world.
In a sense, would you say that the Cranfield results project? Of course, it's a milestone, or it's a important moment, right? But it pivoted away from classification approach to the more IR approach, right? Keyword indexing, that kind of.
I think it did, but I mean that process was really stimulated by the web subsequently. So I mean that's 20 years later. So well, 30 years later actually. By the time we got to the web, and just one search engine, Yahoo, made an attempt to index things in a formal sense, and discovered that it was simply not doable on the web scale. Although it's still the case that scientific abstracts are published with subject headings and things like that. I think it's so much taken for granted now that you want to be able to deal with raw text, and so much work has been done on raw text that these other things might provide some help, but they're not going to solve the problems in a way. They're not going to do it because of the scale on which we expect to be able to work these days. So even internal reports in companies, you typically have great quantities of text, and you typically do not have library staff classifying them. So it remains a sort of web-like situation.
My next question to you, you did make an attempt to unify and resolve the bit of a conflict between your RSJ approach as well as the Maran and Kunz approach as depicted in the 1960 paper. So if you were to be doing active research today, and if you can imagine a time machine, like going back to 1981, do you think that you would have done that? I mean, you would do it today and it would change the landscape of IR research?
It's a fair question. I'd like to try and explain what the conflict between the two models was in fairly simple terms. So in the Marin-Kunz paper, what they imagine is a librarian sitting with a book, a document to classify, and imagining the kinds of, well, if you like, the kinds of people who might find this book interesting and the kinds of queries they would ask. So a good way to index this book is to represent it with the words that a user who would like this book might use. Okay, so the book is the thing in front of you, the individual object in front of you. These users are some abstract class of users. Okay, and you're trying to make the indexing of the book fit this class of users. So that's Marin-Kunz. Okay, Robertson, Spark, Jones. We start from the idea that there's a user with a query. Okay, and the user puts the query to the system and may get some documents back and may find some of them useful. Okay, so having found one or two useful ones, then the question is, how are they characterized? Can I, the user, or the system for me, reformulate the query to find more like these ones that I've found already? Okay, so we're now talking about abstract class of documents which might be like these, and a known individual user. So it's the opposite way around from Marin and Kunz. And the principle of RSJ is that you change the query to find this kind of document. Principle of Marin and Kunz is you change the indexing of the document to find the right users. If you like throw both up in the air, say neither of them is fixed, then you've got a problem. You can't modify one to fit the other at the same time as modifying the second to fit the first, or at least it's not obvious how to do that. And that was the conflict. Nowadays, with many things that happened in the world of machine learning and statistics, you might start with a sort of Bayesian idea, which says something like the initial starting point for the document and the query are these, and that's a sort of prior, and we might sort of modify that slowly to bring them together, if you like, not too much, and not throw away the original. And I did actually have a student who worked on that kind of line. The resulting model was actually far too complex. I mean, it probably worked, and he did test it, and to some extent it worked, but it was just too complicated, and nobody really nobody really took that up, and I allowed it to. I mean, I couldn't see how to make it simple. So if I was starting again now, I would take that kind of approach, but I'd have to enlist the help of some really good sort of machine learning people to work out how to do this in a systematic way. There is a world in which something like this is happening, and that's the world of recommendations. So in recommendations, you have the same kind of pairing. You have people, and who, let's say, users of Amazon, who have certain characteristics which Amazon observes. Okay, they tend to look for certain kinds of things, and you have Amazon objects, which are, or things for sale, which are which certain kinds of people like. Okay, and so the recommendation world is trying to bring those two together. And if I mean, I find the recommendation world in personal terms, I find it rather alien. And rather commercially driven, and I don't particularly want to get into it, but that is a world where this potential conflict between Marin and Koons and RSJ, and the potential ways to get them together really makes sense there. So if I were doing it again, I would probably hold my nose and say, well, maybe I should try this kind of data because there is a lot of it in the world, and try and make sense of a model in terms of this kind of data. I think
in
that's
a way, what Amazon does is like the associative relationship or kind of citation, co-citation kind of thing. If they're together,
yes,
they're associated.
that's right. That's right. Yes, exactly. Yes. Yes.
So, I mean, talking about the probabilistic model, and of course, you already mentioned about the machine learning model, etc.
Yes.
Would you, I mean, all of your, I mean, all other probabilistic models such as BM25 and TF-IDF, and including the page rank, okay, they're
Yes.
all built on these explicit mathematical formulations.
Yes. Yes.
Whereas the machine learning approach is not based on such, and they're more, I mean, do you think that in a way they are sacrificing interpretability for performance?
I think interpretability is a problem with machine learning retrieval, machine learning based retrieval, machine learning based many things, in fact. But I think so. So let me give you some interaction that I had with some machine learning people. So when I was working at Microsoft, and BM25 was being used in various contexts in Microsoft, and when Bing started, which was after I'd been at Microsoft for a few years, it was being used in Bing, and what the machine learning people then found was that so various features are combined in BM25 in a particular way, which is suggested by the formal model, as you say. But as far as the machine learning people were concerned, they could learn how to combine excuse me, how to combine BM25 with other features. But the problem was that BM25 always came out as a very strong feature in its own right. And what they would much prefer the kind of environment in which they would much prefer to operate was one in which you have a lot of weak features, and the machine learning learns how to combine them. So they didn't like the fact that BM25 had a very particular functional form, which wasn't accessible to their learner. And if they worked very hard without BM25, they could achieve about the same performance or something very similar, combining all these weak signals. but a lot of them, a lot like you have on the web. But it annoyed them that they couldn't do much better, which is fair enough. I mean, I think that nowadays on web scale, I've no idea whether the web search engines have anything like BM25 in them now. I don't know at all, because there's so much machine learning been going on in all of them, that BM25 itself has probably disappeared, and they probably do learn everything they need to know. But of course, that depends on the kind of training data that they have, which is huge quantities. For almost any other environment, you don't expect to have those quantities of data. And I still think it's probably quite hard to beat BM25 in any environment that doesn't have large quantities of machine learning data. I think the particular functional form it has proved very robust, and is really difficult to learn from scratch with a machine learning method. Okay. So I think that's the situation. But I mean, you could, so there are realms of information retrieval which not only don't use BM25 but don't use ranking at all. And one of these is legal retrieval. So the world of legal retrieval was, and I believe still is, stuck in the Boolean world. I mean, we've abandoned Boolean retrieval in everywhere else.
Everywhere else, yeah.
Since the 80s, basically. Well, since the 90s, we've abandoned Boolean retrieval. Does not figure in any other context, as far as I know, except the legal world. Lawyers, for some reason, love Boolean retrieval, and they can construct these vastly complicated Boolean expressions to find excuse me, to find documents in a legal corpus, or a corpus of data that's been released for some legal purpose. I mean, like the emails from what was it, Exxon? I can't remember, one of those big trials. They have vast quantities of emails were released and were searchable, but were searched using Boolean expressions.
Is it because the field itself is not cumulative but aggregative, right? In the legal thing,
I suppose that's right, but it has partly to do with the fact that the legal people, with interpretability, as you mentioned, the legal people think they know what they're doing with Boolean logic. I'm not entirely convinced that they do, but they think they know what they're doing. They think they know exactly what will cause a document to be retrieved. And I mean, in principle, the Boolean logic allows that, except that they produce these page-long Boolean requests, which I can't believe that anyone can have in their head. But yeah, so it is to do with interpretability. So that was always the argument that kept Boolean search going quite a long time, when there were already ranking engines which are quite good. Some people preferred Boolean because it is interpretable, because they understand exactly why any particular thing has been retrieved and something else hasn't. Well, they can do anyway.
Talking about Boolean retrieval and, of course, your own probabilistic model, ranking model, I think in one of the papers in 80s, probably, Cooper himself has written about, whether probabilistic ranking model is a boon or an encumbrance or something like that, right? Hasn't he talked about that?
Sure, and I think so. One aspect that it might be worth going back to a bit is relevance. I know that's of
Yeah.
interest to you. The Trek world has tended to think of relevance as a sort of absolute property which a judge can decide.
Yeah.
I've in my mind I've always stuck with something like the Cranfield interpretation of relevance. So in Cranfield relevance, the searcher formulates a query of some kind, and ideally, it didn't always happen, but ideally, the searcher themselves judges relevance. And there's in Cranfield itself, there was a 4-point scale of relevance. Well, 4 points plus non-relevance, so 5 points altogether, which had a description. So it was something like sort of provides a complete solution to your problem, down to is of marginal use, but it's very much a sort of judgment thing by the user. Okay, so as far as I'm concerned, I'd like to think of relevance as a user judgment, which is not really not a matter of logic. It's a matter of what responds to the user's cognitive situation, if you like. And so we therefore can't expect to be able to predict relevance exactly. It's something where we, the information retrieval people, feel our way towards, and it's got noise in it because people make judgments. I mean, people's judgments are necessarily variable in various ways. So it might depend on my mood whether I regard this document as relevant or not to my problem, or to put it a bit more sensibly, it might depend a lot on how much effort I'm prepared to relate the document to my problem. And that might depend on how well it's written, for example. So if it's well written, I might be encouraged to construct the relation between that document and my problem. And if it's not, I might give up and say it's not relevant. So relevance has that in it. As far as I'm concerned, relevance has that in it. And given that, I do think the best that a system can do is to say, this may help you in a probabilistic sense. Okay, so simply the system might have it wrong, not because its logic is wrong or its arguments are wrong, but because as it happens, the user doesn't respond positively to this document. So I think that has to be. I think that idea of subjective relevance has to be allowed for in that way, and that encourages me to use the probabilistic approach.
Yeah, of course. And I believe and I continue to believe that, it's subjective. But one way to
Absolutely.
capture is that, of course, attempts have been made about the relevance feedback mechanism, which
Yes.
continues to be used even today, right? Like,
Yeah.
whether the user clicks, even in searches, whether the user clicks a particular
Yes.
link or not, and then based on their past history, that is the power that Google or search engines have. They know what I have searched for, right?
Yes. Yes.
So
Yes.
that's how
That's
they are
right.
able to.
That's right. But I mean, evidence like that another user put in this query and clicked on this document, that's bringing in the difference between users, because the query is not, as we know, the query is not a full representation of the anomalous state of knowledge. So there's no very strong reason why a different user with the same two or three or four word query should make the same judgment about the next document that comes up. So that's between users, and that's in addition to the subjectiveness of it even for a single user. But yes, that's quite correct. Yeah.
So now with the large language models, etc., this neural ranking models that are used in large language models, do you think it's a real paradigm shift, or is it just in a way, extension of the long-standing IR principles?
I think that the machine learning that has gone into the big web search engines, certainly, and some other retrieval environments over quite a long time now. I mean, since 20 years at least, maybe, yeah, 20 years. I think that's that has incorporated but moved on from basic retrieval principles, and so, but as I said before, you can only do that where you've got a lot of training data. So the information retrieval principles remain important in other environments. Okay, the web is sort of special in a way, and machine learning has moved quite a long way. However, I think the question about large language models and AI is slightly different. That is, we were doing in Trek, we were doing machine learning in retrieval, and indeed the first few years of Trek, information retrieval researchers were coming up with machine learning models of a sort. Models which learnt from relevance judgments. We had a lot of relevance judgments in Trek, so we learnt from them, and the initial models used there were very much homegrown in the information retrieval community. That was in the sort of first few years of Trek. By about 2000, the general world of machine learning was becoming much more active, and people were applying general machine learning models in information retrieval as opposed to making well-known retrieval models learn. I mean, we could make the M25 learn in certain respects, but people were applying generic machine learning models by about the early 2000s in Trek. So that's machine learning, and machine learning's gone a long way from there. So come on to large language models, which is a much more recent invention and has powered the current generation of what call themselves artificial intelligence systems. And they've been very interesting. As far as I know, they have as yet made little impact on retrieval. So you get Google's, what is it, artificial AI summary.
Overview.
Overview, thank you.
Overview, yeah.
So when you do a Google search, you're depending on the query, you probably get an AI overview of the answer. And that's been generated by an AI engine, a large language model, looking at the documents retrieved by Google, not putting requests to Google. So in that model, I do not think that the AI overview machine is in any way interacting with the initial search. So the user puts in search goes into standard Google, results come out, and then the AI looks at them, which is quite interesting, and it does sometimes work, and occasionally it does very, very funny things. But maybe for many people, under many circumstances, it's useful not to have to look through the documents that have been retrieved, but to rely on the AI. But one could imagine, one can imagine an AI helper who would actually help to formulate the query in the first place, who would know about retrieval and about formulating searches. And if we were still in the Boolean world, I'm sure that would happen to you get AI generated Boolean statements as well. But we're not in the Boolean world now. So one could imagine, as I say, an AI that interacts with the search process and helps the user get to where they want to get to, both in terms of the retrieval as well as in terms of interpreting or summarizing the results of the search. But I don't see that happening yet. But the RAG, which is retrieval
augmented
generation. Yes. So that idea seems to invite the AI system to get involved in search in some way. I have very little idea about how far that's got so far, but that might do it.
So
as far as I'm concerned, I sort of think that that any such device will necessarily have a more or less conventional retrieval system at the back of it. Even if, I mean, it will change the situation quite a lot if the artificial intelligence learns how to do the search in a better way, in a good way, and users start relying on that part of the process. But I still think, present generation of large language model AI involves this process of training, initial training, taking in as much as they can of the world that's accessible through text and images and sound and whatever, and reducing it down to a large language model, and that process has to happen before the AI can start working, and then the AI starts working with this trained model, and this trained model is its knowledge base, its understanding of the world. It's entirely in this trained model. Whether you could get an AI, or how you can get an AI to identify cases where its large language model is incomplete or inadequate in some way, and then go to a retrieval system to resolve that incompleteness or inadequacy. That would be really interesting. I don't think it's happening now. I'm fairly sure it isn't happening now, but that world is changing quite fast. So maybe it will soon.
So in that sense, RAG, or retrieval augmented generation, is one way of saying where IR meets AI, right?
Yes.
So and then even in RAG they talk about the building the knowledge base and that kind of thing that you alluded to, and that's what RAG is all about, building that knowledge base. So in a sense, I would say both traditional modern IR meets AI at this point of RAG, or the knowledge base that they're talking about.
I think that's right. Yes.
That's what.
Exactly.
And perhaps if it goes in that direction, only then probably we'll agree that it is actually AI assisted or AI retrieval system.
AI assisted retrieval. Yeah, exactly. Yes.
Until then, it's only extracting and summarizing. Instead of doing the search, the Chat GPT or something will do the search, or Google overview does the search, gets the results. It takes all extracts, of course, naturally stupendously fast, extracts and summarizes and throws out the results. It's not really AI assisted retrieval. So if you were to sort of in this long journey to look back and then look ahead, what would you think are the transformative moments in this journey?
Um, I think I think one of the interesting things in the field, and it's been the case all along, is the way in which people come in from outside with different ideas, and the field. I mean, sometimes in any particular field of study, I believe this is the case. That sometimes you feel that there's a sort of narrow coterie of people talking to themselves and entrenched in some way of thinking about the world. I think, and occasionally that's happened in information retrieval, but I actually think that information retrieval has been very open to people coming in and thinking about things in different ways. I mean, actually, the beginning of web search engines was like that. The people who designed the first few web search engines, very few of them had any connection with the world of information retrieval at all, or any sort of background in the research in the field. So there have been quite a number of transformative moments when people have come in with new ideas. So new ideas are generated within the field as well, of course, and they've been good. And Cranfield and Trek and probabilistic model all come into that category. But we the field have been stimulated by people and events outside. And I mean, to go back a long time in history, way before the web, the thing that got the whole Boolean retrieval field going in the first place was that suddenly, not suddenly, but over a few years, we had available, that is, the information retrieval people had available, magnetic tape databases of scientific abstracts, which were generated by the abstracts journals. And the reason they were generated by the abstracts journals was because the abstracts journals were implementing computer-assisted printing. That was the only reason all the abstracts got put into machine-readable form in the first place, was because they wanted to be able to do computer-generated print, and so this data suddenly became available, and the information retrieval world latched onto that and generated all these Boolean systems that existed from the middle 60s until the late 80s, or early 90s. And were really only sort of rendered irrelevant by the web search engines when they finally came along. So there are outside events which are transformative, and that was one of them. And the web itself was one of them, as I say. So there are events, and then there are ideas generated internally and externally, and there've been a fair number of them. I think the field has been quite at times quite open to new ideas, and has allowed new ideas in. And there have been a number of transformative moments like that.
Okay, thank you. So my final question to you is that now that this, boundaries are blurring between, I mean, people retrieved information in order to create information generally, right?
Yes.
Create new knowledge. So that
Yes.
is blurring with generative AI and all of that. So where do you see that future, which direction it is headed?
I wish I could say. I really don't know. I mean, the idea that we discussed about an AI system which helps with the search is one, and I think that will probably happen. But I mean, I suppose that the vision of some people at the moment is that, in a way, you should never have to ask for information. That is, there should always be something that's telling you in advance what you will want to know next minute, and give you the information and find the sources and present them to you before you realize you need them. And there are elements of that in the world, in the smartphone world today. I sort of have a nostalgia, and maybe it is just nostalgia, for the consciousness of human research, for people deliberately thinking about things and bringing in ideas themselves. And I'd be slightly sad if AI replaced that, I think. As I say, maybe that's pure nostalgia. Maybe it's bound to happen, but I don't. I hope not.
Okay, thank you so much for this.